This is tutorial 4, the electromechanical transfer function. So the goal of this question is to find theta L on EA. We're given this system here. First step is to simplify this gearbox. So I've drawn an equivalent system here. Next step would be to sum the torques about one of our inertias, JA prime. So that's just the torque of the motor is equal to torque of the inertia plus torque of the spring. Subbing in the gear ratio equations up here. So in this case, Tm prime is equal to N2 on N1 Tm, and we just do that for Ja prime and theta M prime as well. Next step would be summing the torques about JL, this second inertia. So that's just 0 is equal to the inertia, the torque of the inertia, torque of the damper, torque of the first spring, and torque of the second spring. We rearrange for theta L, and then we sub in theta L into Tm up here. So that gives us this equation here. The next step would be looking at the electrical side. We have these three equations. We're subbing these two equations into EA is equal to IA plus VB. And then we get this. Then we sub in Tm here to get this equation. And then we take out the theta m's and then divide both sides by theta m to get this transfer function here. So now we effectively have EA. EA would just be theta m times this transfer function. So we can do EA divided by theta L to get the transfer function that we're trying to find. And so we do that. Theta m cancels out by the theta L, this theta m here, and then we inverse both of them. So we flip them both upside down to get theta L on EA. So that's the thing we're trying to find. We sub in the values that were provided by the question and try and simplify it down as much as possible, and this is the equation I got.